This is the fourth question in the Grind 75. This one is called Best Time to Buy and Sell Stock. Grind 75 allots us 20 minutes, and so we're going to start the countdown now. Okay, so you are given an array prices where the element in prices at index I is the price of a given stock on the ith day. Okay, you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Okay. Return the maximum profit you can achieve from this transaction. You cannot achieve any profit. If you cannot achieve any profit, return 0. So let's see. Give me this array. Okay. Maximize by choosing a single day to buy one stock and choosing a different day in the future to sell. So return the max. Okay, I see. So in this list, we basically want to choose. We want to find the greatest distance, and each element represents a day. So we sort of do need to maintain the order of the list as is. And we want the greatest forward difference. So let's see. See if we're, yeah, that's interesting. Okay, this is a cool problem. Let's see. So buy on day 2, price equals 1, sell on day 5. You must buying on day 2 and selling, yeah, obviously you must buy before you sell. Okay, so let's see, how can we do this? So, I mean, we're going to want to look for, I think we're going to keep track of a small value somewhere. So, let me actually just note this. I'll note it on the notepad. So, and we'll go to brush. Smallest val of some kind. Let's see. Does it make sense? Okay. I mean, I want to think of some different data structures for this. So if we're just iterating, starting at 0, we don't have anything to compare it to. Say we move on to the next one. If that value is less than, then maybe we want to keep that value. And then keep going. If that value is greater than, then we will have a current max, seems like. And then we're going to keep going. So I will actually write some notes down here. So basically, so the first value is going to be a minimum. Then we're going to update minimum if possible, and we're doing this as we're iterating. And then if we can't update, then we're going to take the difference, compare to max, update max if can. Okay. And say 4 is our max, that will be some separate variable. We have 1 stored as our minimum, so then we're going to keep going. 3 is not less than our minimum, so we're not going to update. We are going to take the difference between 3 and 1, and we'll note that it is smaller than our max, so we're not going to update our max. We're going to continue. 6 is not smaller than 1, so we will take the difference, see that it is actually greater than our max, and we're going to update our max. And then we'll go to 4, and yeah. So we will have to iterate through every day. It is an O of n operation. There's not really any way to get around this. I'll just mark it really quick on here. Our solution is O of n. And I don't really see any better way to do it, really. It just seems to be an array problem to me. So, but let's see if this procedure holds up with the second example. So, in this one, it's constantly decreasing. So, yeah, okay, let's see. So we're gonna establish the minimum. Update. Yeah, okay. So move on to the next. Update the minimum. So when do we instantiate the maximum? So let's see. I mean, it's possible that ith day. So I think a base case would be if the array is of length 1 or of length 0, then we're going to automatically return 0. So I'm just going to note that here. If input is length 1 or 0, return 0. Otherwise, we can initialize our minimum to be the first value, and then we'll set our maximum to be 0. So initialize minimum as first val, maximum as 0. And then we're going to move on to the minimum, or we're going to move on to the next value. So the minimum is the first, the value at the first index. We're actually going to start iteration on the value in the second index, because we know based on this that we need to have an array of at least 2. And then we're going to follow this procedure. Update the minimum if possible. And if we update the minimum, then there's no need to take this difference. So, I mean, it'll be an if statement, if else statement. Let's see. So, otherwise, in this case, we wouldn't update the maximum either, because we're only updating the minimum, and maximum would be set to 0. So, I mean, this seems pretty straightforward to me, actually. I think I'm going to just come up with a solution really quick. So it's an int list prices. I'm just going to say if do an initial if check if prices dot length is, say, less than 1. Yeah. Then we are going to return 0. That's just an initial if check. Otherwise, we're going to iterate. So for int I starting on the second value in the list, and this will go on for as long as the length of the list minus 1. So while I is less than prices dot length minus 1, and then we'll increment that. So we can actually, I guess, instantiate that up here. So int minimum is going to be equal to prices at index 0, and maximum is going to be initialized to a value of 0. Uh, prices dot length. Okay, the actual elements are always positive as according to the constraints right here, always positive, and the length is 1. So it can't be 0. So I would actually say less than it. I mean, I can just say equal to 1, I guess. Okay. And then let's just carry on. So if I'm just going to say prices at I. If prices at index I is less than our minimum, then we are going to want to update our minimum. So minimum is going to be equal to prices at I, else, so if it is equal to, what would we do if it's equal to? Say it was like 7.7. So if it is equal to, then we could just, I guess we would do nothing, honestly. If it was equal to the previous one, there will always be some difference. If it's equal to a minimum, we don't want to update anything. Obviously then our maximum. So then we only need to check. So if prices is less than, or if it's the opposite actually. So also if prices is greater than minimum, then we will do our check. We're going to take the difference between prices and minimum, and we're going to say int difference is equal to prices at index I minus the minimum. We're going to say if, well, yeah, if difference is greater than maximum, then we're going to make maximum equal to difference. And once we exit that for loop, we will want to return our maximum difference as per the parameters of the problem, the instructions. And I think this is a working solution. Let me just run through it and see if there's something I'm missing. So each element is a stock on the ith day. You want to maximize by choosing a single date by one stock, choosing a different day in the future. Okay. All we need to return is the maximum profit. So I'm going to iterate through example 1. Sorry, so yes, this is the completed code. And yeah, so I'm just going to look through example 1. So again, example 1 had this. I will write it down here actually so we can see on the other screen. 715364. So that's 715364 3, 6, 4, and that's not a phone number. Okay, so actually, hold on 1 second. I just want to see. Okay, we're going to switch over to the code. Give me 1 second. So we're over on the code. That is our example. We are going to go through. So the prices is obviously not 1, so we're okay. We're going to set the minimum equal to the first index, and then the maximum is currently 0. And then we can start iterating on the second index. And if our element is less than the minimum, which it in fact is because 1 is less than 7, then we're going to set 1 equal to, or the minimum is now going to be equal to 1. Okay, so then we would exit from there. We're going to keep going. We're going to move on to 5. In this case, we'll go to the second condition, which is the else if, where the price is greater than the minimum, and we're going to set the difference equal to the current value minus the current minimum, which was reassigned to 1 in the last iteration. And because the difference is greater than the current max of 0, then we're going to update the maximum, and the current max will be 4. And we're going to do so until we get to the end of the list, and I mean that should work. The only thing we should be wary of is any base cases, and the list can only be a minimum of length 1, so we've accounted for that. Say we had a list of 2 elements, and maybe it was like 7 and 6. So say it was just like the second example, just the first part of the second example. Just to write it out, say it was just like 7 and 6. So I don't really think there'd be anything wrong with our logic. Minimum set to 7, maximum set to 0. We'd go through the for loop once. Let's see. Price at that element would be less than our minimum, so we'd update the minimum. But then again, the maximum would still be 0 because there was never an increase. Likewise, if we had 6 and 7, the difference would be 1. Maximum would be updated accordingly, and we would return maximum. So it seems like we have a working solution. And let's check the timer. You have minute and 40 seconds or so. So let me actually, here, well, there, yeah, minute 30. I'm just going to hit submit because I'm pretty sure this is right. So let's take a look and see. All right, so 1 and 2 yielded 0. Why is that the case? Prices.length minus 1. It seems like we're not entering this loop because we're starting at 1, but this is of length 2, and we're terminating as soon as we hit the last index. So while I is less than or equal to is what we should be saying. And let's see if that's right. Okay, that's funny. All right, well, that's our working solution. I'm pretty sure the actual one is pretty close to that anyways.